Alright, hell yeah. So we have problems in general physics. This is Irodov, and we're going to try to solve this fast as hell. Okay, so we got a ball. It falls from a height, and it falls on an inclined plane. You know what I mean? So if it falls from that height, it bounces elastically. You know what I mean? So it's going to bounce like a oh, damn it. So yeah, just right off the bat. So I don't want to do anything wrong, but no, it's gonna bounce like a pool ball. So this is the tricky thing. I'm just gonna say, check this out. So let's say your angle is real small. Then if this height comes in, and then it bounces, like obviously this is gonna be normal, and then so if it comes in at that angle, it's gonna leave at that angle. Okay, hell yeah. And this angle right here that it comes in is real small compared to that. So hell yeah. So this is kind of your, oh, I shouldn't be teaching, but that's your theta. And then so here's your theta, and then here's your phi. I always do 90, you know what I mean? Because if this is 90 degrees, so, I mean, theta is equal to alpha. So hell yeah, just for this problem. And I might use theta. And okay, so then holy crap. So it's going to leave at a velocity, I mean at an angle of 2 theta from the vertical, you know what I mean? So that sucks. So now we want to know what this is from this direction. So I'm going to say this is phi prime, you know what I mean? Because who cares about that one? But this is the one that we're most interested in, and this is going to be phi. And phi is 2 theta, you know what I mean? So 90 degrees is equal to 2 theta plus phi. So phi is equal to 90 minus 2 theta. And in this case, 90 minus 2 alpha. Okay, hell yeah. So now we have, so the velocity incoming, which would be the max velocity at that point. This is height, so we have to use energy. Potential energy is mgh. Kinetic energy at that point is 1/2 mv squared. Those two are going to equal each other. And so if they're equal, masses cancel. 2 goes up there, so we got 2gh is equal to velocity squared. So we got velocity is the square root of 2gh. Cool, so now we have our initial velocity with an angle of phi to the horizontal. So then, hell yeah, you know, we can say our vertical component of our velocity in the y is v naught, which here's the equation for v naught, and we're going to say v naught sine phi. Cool, hell yeah. So this is going to determine how long it's in the air. So then from this, we know that acceleration is gravity g, and that's going to be downwards. So we're going to, you know, what should we do? We're just going to say g is negative 10, okay? And then we'll just keep that as a positive value. But you get it, acceleration is negative. Acceleration is change in velocity, change in t, which is dv dt. Separate variables, and we say this is equal to g. So separate variables, we get an equation for velocity is gt plus the initial velocity plus v naught sine phi. Integrate again, you know what I mean? Velocity is dx dt. Separate variables, and we get position is 1/2 gt plus velocity initial sine phi t. And then plus the initial position. We got to pick an initial position, so we're just going to say that's x is equal to 0. This ball is going to go in the negative, be negative. So, but at least right here, hell yeah, the first bounce is going to be 0. All right, so it says once it bounces, at what distance from the impact point will the ball start to bounce a second time? It really should say at what angle, too, is going to be the, you know, that would be a fascinating. But at what distance from the impact point? I think they want distance down the slope, but it doesn't really say. At what distance from the impact point will the ball rebound for the second time? Okay, hell yeah. I mean, so that distance is going to have an x component this way, and then a y component this way. And holy hell, this is y. This is the y direction. This is velocity in the y. So you do the same thing in the x. Acceleration is 0 is equal to dv dt. Get an equation for velocity. That's just going to equal the initial velocity in the x. Velocity in the x is v naught cosine phi. So we just have v naught cosine phi. separate variables, and then we can get a position for x. And that's going to be v naught cosine phi of t, and we're still, this is the origin, 0x, 0y. Okay, hell yeah. And then so, but at some point, you know what I mean, we got two different things going on here, because we can't just say when x is 0, when we can't just say when y is 0, it's going to impact. No, it's going to be at some sort of negative y. It's going to impact. It's always going to be less than, you know what I mean. So let's just, what do? You just pick, this is where I guess the problem gets sucky. Holy Toledo. Because if in the x we were to there, where it can still fall on a trajectory, so you're going to get more x, you know what I mean, and you know what I mean, and then more x and more x. So damn it, this is where the problem gets hard. But focus. So what's the relationship? Okay, so we have x and y here. We need to find, we have the slope of this line, you know what I mean? So if here's our angle, and, oh damn it, oh yeah, so here's our angle from there, and what's the slope? It's going to be rise over run. If we do tangent of our angle alpha, that's going to be y divided by x. And we know the slope is going to be negative y over x. Okay, so we know the slope is going to be negative tangent phi, and we know the equation of the line is mx plus b, and sweet. And so we know we're going through the origin. So our equation for this line is y is equal to negative tangent of the angle times x. Cool. Hell yeah. So now at the point where these two, so now you actually just throw these two, if this is my x term and this is my y term, and the only place that it can impact is when those two are going to be satisfy this equation along that line. Oh hell yeah. This isn't going to be a 10 minutes or less, but we're pretty damn close. All right, gt v naught sine phi. But this is your continuity. That's the hardest part about every problem, is just friggin' finding the continuity. And if you didn't want to do, is there any way? I don't know. Could you do this in x squared y squared? You know what I mean? I have no idea. Or like the Pythagorean theorem? Probably not. But anyway. So let's just do it. So we got v naught cosine theta of t, and at least from this we can figure out when the t is going to happen. So this is oh damn it, you know what I mean, this is squared. So you know what I mean, I would have caught that. But hell yeah, it's actually going to be fairly simple, because we can get this to this side, set it equal to 0. So hell yeah, see how I just did that? And then we just did positive. Okay, booyah. So we got that the hell over there, set it equal to 0. We're going to factor out a t. And then so these t's go, those t's go, and then we're just left with one t here. Okay, hell yeah. So if this equation is satisfied, so at t is equal to 0, hell yeah, we're impacted. And then when this equation, so now we have a full separate equation when this is equal to 0, hell yeah, so let's get this crap the hell over there again. And just remember, g is negative 10, because when we get this stuff over there, it looks like all this stuff is negative. Well, it is, and we're just going to do it all in one go. We're going to get the 2 upstairs and then the g downstairs. So we're going to have time is equal to negative v naught sine phi minus tangent alpha v naught cosine phi, and then just divided by, what would we say, the 2 goes upstairs, the g goes downstairs, and hell yeah. So that's the time that's going to happen, and it says at what distance from the impact point where the ball rebound the second time. So actually, you know what I mean, this is where it's going to impact. So at this time, we want to know the distance from the impact. Oh, what is the distance from the impact point the ball will rebound for the second time? Well, this distance, oh, damn it. All right, hell yeah. We didn't do the 10-minute mark, but we're so close. So this distance d is equal to x squared plus y squared. You know what I mean? So, I mean, you can get really heady with this, and it's the square root of that. So let's do it. Let's just get one friggin' equation and call it good. And if I made an error, I made an error. Like, who gives a crap? But anyway, so we're just going to throw these values in. This is my value for t. Can I clean it up? You know what I mean? I just wish g was positive, you know what I mean? So let's do that. We're going to say g is going to, I don't know. No, we'll just leave it as is, just with all the stupid negatives. But we can factor out a 2v naught, and we can do a negative 2v naught, hell yeah. And then we can do sine phi plus tangent theta cosine phi. Cool. And divided by 2. I mean, sorry, divided by g. And even here, you know what I mean, it's not going to be super good, because what the hell was phi? Phi was, solving for phi. Phi was 90 minus 2 alpha. You know what I mean? And I just don't want to write that in for every time. So, I guess just the quick answer. Well, no, let's write it out. So we have x squared. So we're going to have square root of v naught squared cosine squared phi. Oh, I guess hell. We'll just write 90 minus 2 alpha times t. So that's going to be negative 2 v naught sine phi plus tangent alpha cosine phi. Divided by g. Okay, hell yeah. So, and guess what? Did I already mess up? Well, this is going to be squared too. You know what I mean? So, cosine squared, and then this is going to be squared. Instead of squaring the entire thing, I just did it piecewise. So now we have y. So we're going to take this y equation and square it. So I guess we'll just do this. So we got 1/2 g. Now we got to take this craziness, 2v naught sine phi plus tangent. Tangent alpha cosine phi divided by g, and then we're gonna square that, and then plus v naught sine phi, and then that for t again, 2v naught sine phi plus tan, you know, I think you get it, divided by g. There's my t, and then, well, you know what I mean, and then we got to get a parentheses around all that, square it, and then take the square root of the whole damn thing. And even here, I didn't pop in phi is equal to 90 plus 2 alpha. But there you go. Like, obviously, you would just solve this first and then throw it in. But I think you get it, and we don't want to make this video any longer. And I could have made an error, but I think I'm actually pretty decent. I felt pretty confident in my ability not to make errors on this one. So I don't know, you know what I mean? If it says at what distance from the impact point will the ball rebound for the second time, I mean, it just gives you, you have to get the equation in terms of, so yeah, we did it. We basically did it at this. T is equal to there. So if this is my t value, then you just do this, is dx, and then you throw in your x and you throw in your y into this equation. And so these go into this equation, and then your t has to satisfy these two equations. And that's your distance. Alright, so that was doing it fast in under 15 minutes. But people are just like, oh, why didn't that just take 5 minutes? Well, it's just like, well, that's why. You know what I mean? It's just, if this was test time, this would not be a problem on a test. I mean, but, I don't know, it could be. I mean, we got there pretty fast. It's just writing out the whole damn thing isn't worthwhile. Getting into smaller equations until you get, you know what I mean, getting into smaller equations, finding the continuity, and then setting up the final equation, and then everything else, then you're good. Doing this is nonsense. Alright, so thanks for joining me, and guess what? That's a video.